Here's a problem where they're asking us about noble gas configurations. In order to answer this, you need a periodic table, and you need to know something about electron configurations. Note the charges on each of the ions. If the size of the charge corresponds to the number of steps away from the noble gas or the edge of the periodic table, if you're on the left side, since almost all of these are positive ions, then you're looking at reducing the number of electrons. Then you would have a noble gas configuration. So in question A, iron on the periodic table is right in the middle of the transition metals. So losing 2 electrons or losing 3 electrons doesn't bring you to the edge of the periodic table. It doesn't bring you to a noble gas configuration. Scandium, if you look where it is, it's element 21. It's on the very left edge of the transition metals, and it has an electron configuration that ends with 4s2 3d1 when neutral. Well, if it has a 3 plus charge, then those valence electrons go away and you've got argon's configuration. And then lastly, cobalt is much like iron. It's in the middle of the transition metals. And so losing 3 electrons from cobalt does not give you anything close to a noble gas configuration. Okay, look up thallium. Thallium is element 81. It has a configuration that ends with 6p1. Losing 1 electron won't help you achieve noble gas configuration. Tellurium, though, element 52, has an electron configuration that ends with 5p4. That's just 2 steps away from filling the 5p sublevel and thus becoming a xenon configuration. So yes, tellurium with a 2- charge would have a noble gas configuration. Chromium is like the other transition metals. It's in the middle of a big block. It's losing 3 electrons from chromium will not give you noble gas configuration. Okay, how about plutonium? If you look up plutonium, it's in the inner transition metals. It's element 94. It's smack dab in the middle of the inner transition metals. That's not losing 4 electrons from plutonium does not give you anything close to a noble gas configuration. Cerium, though, Ce, that's element 58. It is, and it actually, if you look closely at the periodic table, element 58 would be precisely 4 steps away from the noble gas xenon, whose element number is 54. So if you're cerium and you lose 4 electrons, you've got the xenon configuration. So cerium with a 4 plus charge would have a noble gas configuration. Titanium, that is not anywhere close. Even if it's a 3 plus charge. If it were a 4 plus charge, then we could talk, but it's a 3 plus charge. Element 22 is titanium. It's 4 steps away from the edge of the periodic table, not 3. So that's not a noble gas configuration. Barium. Well, barium ion is something we've seen before. It's in the alkaline earth metals, absolutely. When barium ion loses 2 electrons, you've got a xenon configuration. Platinum, PT, is not, if you give it a 2 plus charge, that's not enough to bring it to a noble gas configuration, and neither is the case for manganese, which is in the middle of the transition metals, and losing 2 electrons would not help you. So the correct answers, once again, are scandium with a 3 plus charge, tellurium with a 2-, cerium with a 4 plus, and barium with a 2 plus.